Okay, let's implement convolution neural network now. Okay, let me create a copy of the previously completed notebook, and let me give a good name to it. Convolution, convolution neural net. Right. I think this should be fine. Let me make a demo. Okay, in the first sections we are importing the same set of dependencies, but we don't need these SGD anymore. So we are happy with this Atom optimizer, and pretty much we have covered most of the things here. And the additional things whatever we'll require now, we are going to import it them. Chaos layers. Let's import the most important convolution layers, and then max pull layers, and along with that let's bring the dropout as well, and let's bring the flatten first, and then batch normalization. It's good to have. Okay, this cell I don't need. Chaos version. Let me delete it. Let's keep it. Okay. So in this section we are importing the NumPy and required matplotlib libraries. And let me set some seed for NumPy. I'm writing 1, 2, 3. You can take your favorite 42. Loading the data. The shape is 28 by 28. We need to reshape it. Let's reshape it to make it one channel, 28 by 28 pixel. So now new shape is 28 by 28 by 1. Now it's a maximum value of any particular cell is 2255, so we have normalized it. So rest of the things I'm going to keep it as is. Okay, let's proceed further. Okay, so from these sections we don't need anymore, so I'm creating new cells here. So let's give some good title here, good name here. Define the variables. Primarily I'm writing down the hyperparameters here. You can play later with these components. So this is my first convolution layer content. This is second convolution layer content. Let's create the third convolution layer as well. 64. Alright, so this is my first dense neural network. How much? It's 120. It should be fine, should be sufficient. Yeah. Second dense layer, 128 should be fine. Again, you can play with these values anytime. Let's make the dropout as 0.25, or you can, oh yeah, 0.25 should be fine. Now let's create the model. I'm giving the title here. Define the model. Architect. Model is sequential kind of model we're creating. Now I'm going to add our first convolution layer here. Okay, so I'm going to use the first value there in conv1 a. Okay, it's taking a bit longer time to come. This is kind of number of filters. This is kernel size. I'm going to pick up 3 by 3 here. Okay, come back. Yeah, and strides. We do one by one. What else? Activations. I'm going to use railway activation here. And for the first layer, we have to get the input as well. The input shape is 28 by 28, and channel last is 1. So I'm adding the second convolution layer here. Okay, let me add max pool first. Okay, max pool layer 2D, and we have to specify the pool size. Pool size equal to, I should have taken it as hyperparameter. Anyway, I'm hard coding it as of now. Strides equal to the same as pool size. We're going to take it as 2 by 2. 1 by, yeah, it should be 2 by 2. Alright, now model, I'm going to add second convolution layer here. Pretty much the parameters value should be same, other than the number of filters we have. So we are going to pick up the second parameter, and kernel size is same. Let me correct it. So okay, so we're good. We are going to add another max pool layer. No change required. Max pool convolution 3. Okay, so here I have added 3 convolution layer and 2 max pool, so I'm going to add another max pool layer here with the same configurations. Now I'm going to add the I'm going to make these from multi-dimensional to a one-dimensional array using this flatten, and here I'm adding the dense network. First dense network, which will have 128 parameters, and the activation is by default we are taking a ReLU. Okay, nothing else required here. So you can specify the dropout. You can play with the dropout values here and there. Maybe that is your task. You can play later once you have tested your model is working fine. Okay, so number of output, number of in class, let me create this variable. Okay, I'm going to use it for the final dense layer, and activation would be softmax. Okay, pretty much it looks like we have covered most of the things. And
5 minute पे चलता है.
filters. Okay,
5 minute पे चलता है. अच्छा.
filters, it should be filters.
अच्छा. Okay.
Let's see the model summary now. Okay, so we have 49,000 parameters. It's pretty less. Okay, we can see here the third max pooling is reducing it to one content. Okay, so that is not good. Basically, we don't need this third convolution layer at all. Okay, so we can see the third convolution and third max pooling is reducing our content completely. Okay, and before that we can see the image size has reduced to some abnormal content. So what we have to do, we have to specify the padding here. We're going to use the same padding, so that means same size image would be retained. In the convolution layer itself, it is not going to reduce the image size. So I'm applying it for all 3 of them, and so we're good now. Now here you can see already we have 7 pixel image, 7 by 7 pixels, and next we are reducing it to 3 by 3 pixel image. So this third convolution layer is not at all required. So let's get rid of it. Excuse me. Okay, now it looks something pretty interesting. This is the parameter I'm going to remove it. Okay, so I'm increasing the second convolution layer filter counts. Yeah, so we have 428,700 different parameters to tune to find out the global optimum. So let's compile the model. Give me the title, and I should use the same content as below, but let me write it down. Okay, we are going to use loss function as a categorical cross entropy. This is a multi-class classification problem. And what next? We are going to use optimizer, our favorite atom. We're going to use atom optimizer, second order learning rate. So I'm using accuracy metrics for model performance. So I don't need this content now, so I'm going to remove it. So I'll keep these execution details from the previous intermediate dense layer neural network for our reference, so that we can do a side-by-side comparison. So let me do a model fit now. I need to reduce the batch size a little bit so that the number of parameters got increased. Let me test it with one epoch first. Rest of the things I'm going to keep as it is. Okay, our model is running. Yeah, I just fast forwarded the executions, but you can see that in the first iteration itself, first epoch itself, we got around 96.5% accuracy, and it took a bit longer time, around 1 minute to complete. So I'm executing for 5 times, and I'm going to fast forward these contents. Okay, so it's completed now. So after 6 epoch, we got around 98.7% accuracy. So I'm sure if you train it a bit longer time, then you are going to get much better accuracy. So let's see. Previously we got after 50 epoch we got 97% accuracy. Here after 6 epoch we got 98.7% accuracy. So if we train it more than 20 epochs, you are going to get 99 point somewhere 23 very easily. So what we're going to do now, I'm going to predict on the test data, and I'm going to find out all the misclassified content. So yeah, this is the content I got. So you can see some of the examples are pretty difficult to predict. Even with the human eyes, we don't know what those are, especially these sort of things. But there are definitely some scope